There is no milk in the fridge. There is no fridge. Your child is 18 months old, has a handful of teeth, and cannot chew a strip of dried reindeer. Everything the camp eats is tough. Sinew, root, marrow bone, half-burnt fish. So what actually goes into that child's mouth? And how long do you keep nursing? It sounds like a question with no possible answer. It isn't. The answer is written inside the child's teeth, one day at a time. And we have learned how to read it. Enamel is the hardest tissue your body makes, and it has one strange property. Once it is laid down, it never remodels. Bone rebuilds itself. Enamel just sits there. The cells that build it work in a rhythm. They lay down a band of mineral, pause, lay down another. Under a microscope, those bands look like the growth rings of a tree. The rhythm is roughly daily. Count the lines, and you are counting the days of a person's early childhood, in order, with almost nothing lost. And there is one line that stands out from all the others. It is thicker, darker, and it appears in every human tooth that was forming at the moment of birth. It is called the neonatal line, described by the American dental researcher Isaac Schour back in 1936. Being born is physiologically violent enough to leave a scar inside your teeth, so you have a fixed 0 point and a daily calendar running out from it. Pick any spot on the enamel and you can say how many days old that child was. The biological anthropologist Tanya Smith spent years on this and wrote it up for general readers in her 2018 book, The Tales Teeth Tell. Teeth are the best clocks in the body, but a clock only tells you when. It doesn't tell you what the child was eating. For that you need the second half of the trick, which is chemistry. While enamel forms, it pulls trace elements out of the bloodstream and locks them in place. Whatever was circulating in that child on a Tuesday is still sitting in that Tuesday's layer. The useful one is barium. The placenta blocks most barium from reaching a fetus, so the enamel formed before birth is almost clean of it. Then the baby is born and starts drinking milk, and barium arrives. The signal jumps at the neonatal line and stays high for as long as milk is the whole diet. When other food enters, the curve changes shape. When nursing finally stops, it settles to a different baseline again. The tooth records the switch, dated to within weeks. Christine Austin and a large team published this in Nature in 2013. They tested it on macaques whose feeding histories were known day by day, and the chemistry matched the records. Then they turned the same laser on a Neanderthal molar from Scladina cave in Belgium, a child who died roughly 100,000 years ago. The tooth said, exclusively nursed for about 7 months, then other food alongside milk. Then, at around 14 months, the milk signal stops, not tapers, stops. Nobody knows why it ends so abruptly. It could be illness, a new pregnancy, or the mother's death. One tooth cannot tell you. That honesty matters because the number is strange, because everything else we have points to a much longer nursing period. And the other evidence comes from a completely different chemical system, which is why people take it seriously. Nitrogen isotopes. A nursing baby is, in a sense, eating its own mother. It sits one step up the food chain from her, and the ratio of heavy nitrogen in its tissues rises. As the child takes more outside food, that ratio falls back toward the adult level. Sample the layers of dentine down a tooth root, and you get a curve, year by year. Across Upper Paleolithic and Mesolithic burials, the curve usually finishes somewhere between 2 and 4 years old. Not one clean number, a range centered near 3. That fits the living evidence. Among the Juhoansi of the Kalahari, studied in detail by Nancy Howell and Richard Lee in the 1960s and 70s, children nursed until roughly 3.5. Melvin Connor and Carol Worthman published a striking detail in Science in 1980. Those infants nursed in short bursts, roughly 4 times an hour through the day. That is barely feeding. It is a constant hormonal signal, and it suppresses ovulation, which means nursing length is also birth spacing, and birth spacing is population growth. 4 years between births instead of 2 changes everything about how fast people could fill a continent. But I want to be careful here. We are talking about a few dozen teeth, so hold the number loosely. Around 3, with wide error bars. The harder question is what those toddlers were chewing in the meantime, because milk alone stops being enough. From about 6 months, researchers generally agree that breast milk alone runs short on iron and calories for a growing infant. Something else has to go in. The oldest answer, and the most widespread one in the ethnographic record, is pre-mastication. An adult chews the food, then passes it mouth to mouth or by hand. It sounds unpleasant to modern ears. It is also a complete solution. Any tough food becomes soft food if someone else's molars do the work first. Then there is marrow. Warm, soft, enormously fatty, needs no chewing at all. Split a long bone and you have something close to a purpose-built infant food. Brain, liver, roe, the softest organ meats. And honey where they could get it. Though today doctors advise against honey for babies under 1 because of infant botulism. Ask yours. And the assumption that Ice Age people had no way to grind food turns out to be wrong. That is one of the nicer corrections of the last 20 years. In 2010, Anna Revedin and colleagues published starch grains recovered from grinding stones at 3 sites: Bilancino in Italy, Kostenki in Russia, and Pavlov in the Czech Republic. 30,000 years old. They were grinding cattail and fern rhizomes into flour. Add water, put it near a fire, and you have porridge, which is exactly what a weaning infant needs. Boiling is older than pottery too. Hot stones dropped into a hide-lined pit will bring water up. The earliest known pots, from Shinrendong Cave in China, are about 20,000 years old. So soft food existed, which sharpens the question rather than answering it. If you can make porridge, why keep nursing until 3? The best answer researchers give is not about calories. It is about contamination. Breast milk is sterile and immunologically loaded. Standing water and hand-ground root mash are neither. Before clean water, weaning a child early was the single most dangerous thing you could do to it. Nursing is a safety net stretched across the deadliest years of life. But the net costs. A nursing mother is tethered. She carries the child on every foraging trip, thousands of miles over the 4 years before the next birth. That is a hard limit on how far she can range and what she can carry back, which is why the chemistry ends up telling us about people other than the mother. Sarah Blaffer-Hrdy argued in her 2009 book, Mothers and Others, that humans are cooperative breeders. We are the ape that hands the baby over. Pre-masticated marrow can come from anyone with teeth. A grandmother, an older sister, an uncle. Long nursing plus early solids only works if the camp is feeding the child too. Which brings us to the teeth that do not fit the story, and which I think are the most interesting thing in this whole field. In 2020, Alessia Nava, Federico Lugli, Stefano Benazzi, Marco Perazzani, Wolfgang Muller, and colleagues published 3 Neanderthal milk teeth from northeastern Italy in the journal PNAS. They ran a laser across the daily layers. All 3 children started solid food at 5 to 6 months, consistently, which is almost exactly the modern medical recommendation. Neanderthals, somewhere between 40 and 70,000 years ago, hitting the same developmental window we do. That is either a deep shared biology or a coincidence, and specialists genuinely disagree. Some read it as evidence that Neanderthal infants had enormous energy demands from fast brain growth. Others point out the obvious limit. A milk tooth only records early life. That is where I land. Those Italian teeth tell us when solids began, not when milk ended. They are not a 7-month weaning. The Belgian child's hard stop at 14 months is the real puzzle. And it may just be one unlucky child. We are generalizing from perhaps a dozen individuals scattered across 100,000 years. Anyone who gives you a confident single number for Ice Age weaning is overselling the evidence. What the teeth do support is this: milk for years, real food from around half a year, and many hands doing the chewing. A toddler fed by a whole camp, and every one of those days is still there, stacked in enamel, waiting. Your own teeth have a neonatal line in them, marking the day you arrived. You are carrying the same diary.